This video is about midsegments, and this video will address one CCRSM standard to prove that the segments joining the midpoints of two sides of a triangle is parallel to the third side and half the length. Instead of proving the midsegment theorem, which I do in a different video, this video will introduce midsegments and also look at applications of this theorem. Let's get started. Let's first define a midsegment. A segment that connects the midpoints of two sides of the triangle. So here's a picture of a triangle. And if I connect this midpoint with this midpoint, what I get here is the midsegment. Okay? The midsegment of a triangle. Okay? And the triangle midsegment theorem says if a segment joins the midpoints of two sides of a triangle, basically meaning it's a midsegment, then the segment is parallel to the third side, meaning this is parallel to this side, and is half the length of the third side. Meaning if DE, this length, I have no way to notate that, but if this length of DE is some number like 10, then AC would be double that at 20. Okay, that's the midsegment theorem. This is proved in another video, but this video is defining this and also looking at some applications of this theorem. So let's look at some applications of this theorem. Number one, a large triangular window is segmented as shown. In the diagram, DF and EF are midsegments of triangle ABC. Okay, so I need to find DF. Well, this segment right here is DF. That is a midsegment because they said so. Okay, so I can use the properties from the midsegment theorem that it's parallel to this side and half the length of BC. So what is half of 90? It's 45. So DF, the length DF, is 45 inches. If they give you units, then you give your answers back in units. Okay, the next question is to find AB. AB is right here. That's not a midsegment, but it's parallel to EF, and they said that EF is a midsegment. So these are parallel, and I know that EF is half of AB. Well, if it's half of AB, then I double that and find that this is 90. So AB is 90 inches long, so that when I take half, I get the 45 that I see in EF. Now, 1B says consider triangle ADF. That triangle is right here. What is the length of the midsegment connecting the midpoints of AD and AF? So if we draw that in, this midpoint and this midpoint, and connect those, what is the length of this? Well, I got to remember back that I already found that DF is 45 inches. Okay, so I know, again, I'm looking at just that blue triangle. The third side of my blue midsegment is 45 inches. So this length right here, this midsegment of the top blue triangle, is half of 45 inches, or 22.5 inches. So I'm just going to say 22.5 inches. Okay. In number 2, I'm looking at triangle QRS, and I'm told that points T, U, and B are midpoints. And what are the lengths of TU, UB, and QR? So let's first look at TU. TU, let's see, is right here. That's parallel to this side and half the length. So it's half of 40, and so TU is 20. UB, let's see here, segment UB is right here. That is a midsegment because it connects midpoints, and it's parallel to this side and half the length of 50. So half of 50 is 25. All right, QR is here. QR is not a midsegment, but I'm told that there's midpoints, and so this is the midsegment of 30. And so I know that QR is TB, which is 30, is half of QR. So I can double 30 and find that QR is 60. Okay? So the idea is that the midsegment is parallel to the third side and half the length. It's that idea over and over and over again. Okay, there's one more I want to look at together that has to do with the lines being parallel, and that's being important. So number 5 here says, what is the measure of angle VUO? So VUO is right here. Okay, and that's all I really have to go off of in the diagram. Okay, now looking at the diagram, I know that this length is the same as this length, and this is the same as this, which means that U and V must be midpoints, which means UV must be a mid-segment. Okay, that seems appropriate on this in this exercise. Now, the mid-segments theorem states that this is parallel to the third side. Okay, and that's important for us. I'm not asked anything about lengths in this problem. It's all about angles. Okay, and looking at this angle that I'm given here, 65 degrees, and this angle right here that I want to know, those are actually, let's see here, I have parallel lines and I have a transversal going this way. This angle and this angle are corresponding angles. Okay, and if the lines are parallel, then corresponding angles have the same measure. So this is also 65 degrees because they're corresponding angles. So 65 degrees because UV is a mid-segment, therefore segment UV is parallel to segment NM, and they are corresponding angles. All right, this video introduced midsegments and looked at some applications of the midsegment theorem. Thank you so much for watching.